In this video we solve a preliminary exercise in analysis of PDEs. We have this PDE in omega and homogeneous Dirichlet boundary conditions on the boundary of omega. The function u and f belong to these spaces. U belongs to the classical H1 omega Sobolev space. The function f is a square integrable function, so belongs in L2. And w here in the PDE is just a vector with two components, eta and 0. We have only the x component. Eta and lambda that you see in the PDE are strictly positive coefficients. And the first question that we have to answer is what is the type of this PDE, and the second question is to find the weak form. So we have the Laplacian of u plus w gradient of u minus lambda u equals f, and w is the vector with two components. So it's Laplacian of u plus eta 0, and this is partial u, partial x, and partial u, partial y. So we get a scalar PDE plus eta ux plus 0 uy minus lambda u is equal to f. Or this can be written as uxx plus uyy plus eta u of x minus lambda u is equal to f. So A, the coefficient of uxx is 1, the coefficient of uxy, the mixed derivative B, is equal to 0, and the coefficient of uyy is equal to 1. B squared minus AC, we compute this quantity, this minus 1 is negative, so the PDE is of elliptic type. Is a convection diffusion equation. This is a convection diffusion equation. Is of elliptic type and is convection diffusion, and the second thing to do is to find the weak form. So we take function phi in H01 of omega. So the function vanishes at the boundary, is the test function. And this is my test function. Laplacian of u plus eta ux minus lambda u is equal to f. I multiply times phi, and I integrate over the bounded region omega. Now I use integration by parts. I use Green's formula to integrate by parts, Green's identities. The first Green's identity. The function phi vanishes at the boundary, so this integral is 0. So what I have is minus the integral over omega grad u grad phi d omega minus lambda integral over omega u times phi d omega plus eta integral over omega ux times phi d omega, and this is equal to the integral over omega f times phi d omega. I multiply both sides by minus 1. So I have the integral over omega grad u grad phi d omega plus lambda integral over omega u times phi d omega minus the integral over omega eta ux times phi d omega equals minus the integral over omega f times phi d omega. So I can write at the left I always write the bilinear form. This is the bilinear form. And this is the linear functional. So this is my weak the weak problem. Find u in h1, phi in h0, 1, such that this is equal to this one. The bilinear form is equal to the linear functional. This is the bilinear form. This is the linear functional.